Hi, good morning, everyone. Can you hear me?
Mhm.
Okay, great. I assume you can see the slides. Yeah, I'm Harry. I'm from Uber, and I'm a director of Uber Networking. So here is a brief introduction of my team. So my team has the infrastructure part and the service mesh inside the software network part together with RPC. So yeah, just as Ratu says, we have kind of a vertical view of the network. And this is the outline of this talk. I'm relatively new to Uber, so that I will give you a brief history, and I can learn in Uber about the service meshes, and I will give some spotlight about our recent progresses in building the massive scale of the service meshes. And I also will mention about some challenges we see and the research opportunities that to academia for the future collaboration between us. Yeah. First, so for service mesh, I think we design service mesh majorly for three goals. One is just, how to discover the service, and the second is how to know how well the service runs. And based on the information, we design the routing and the load balancing strategy, so that we can survive in this kind of massive microservice world. And but over the time in Uber begins in 2009, and at that time you think back, the cloud is still a new concept, and so that's service mesh or container. So we can build everything from scratch. But at the beginning, you can envision one to run the business fast. What we did is we didn't even have a kind of a microservice concept. We have a big service, and we rely on the mobile to use the static configurations to finish the service discovery and routing, and we rely on applications for the health. So it works well until we have more number of services. For example, one is reached to 1,000. We find it's never scale. So we find, okay, a monolithic service doesn't work. So we split them into services. And in the second generation, we rely on the edge to do the internal routing and keep the mobile kind of transparent. And at the other time, we use HTTP proxy almost everywhere to finish the service discovery and the load balancing and routing, and also the health checking. So, and here the health checking is just from point to point, it's checking the edge rather than nodes. And as the number of services grow further, we realize this model has challenges like the complexity of health checking and the routing. So we realize we need to have a dedicated service to handle the discovery, health checking, and the routing. And the first attempt we tried is to build a cluster, a dedicated cluster, and rely on gossip protocols, to do the announce and the request forwarding. And we actually deployed in the production and for a while. So this works well when we have relatively 1,000 services, but when it goes on, we realize the gossip protocol and the complexity of this dedicated service is too high. So that only after 1 year, we jump to the solution that we're familiar with currently, which is we call the sidecar solution. We call it Martly. Is an in-house solution built in Uber, and we support multiple protocols. For example, we have a private protocol called T-channel based on HTTP. We have HTTP2 and gRPC. And the other thing we learned from our last solution is we need to separate the three functionalities. So we cannot mix them together to make it too complicated, so that we separate the control plane, forward plane, and build different modulars for different purposes of control. So this worked well and support us, from 2016 even to now. So currently we have way more than 5,000 services, and it works well. And over the whole process, here's the lessons we learn. And with the time, you can see, and there was a doubt, whether a smart software network is needed. But over the time, we show that is a kind of a very reasonable selection, and to support the larger scale microservice. The second lesson is, but the service mesh itself should be simple. The architecture should be simple. It should be modular, and because sooner or later, because it is smart, sooner or later it will become another giant or monster that you have to handle. And the third one is related. You can find as the system evolves, business evolve, we will see multiple rounds of migration. So now the migration and the changes the solution of service mesh and the operation of the service mesh is actually extremely difficult, just due to the closeness of the application. Because when you migrate, want to change anything, it have a huge fan out to all the applications, and currently it's not well decoupled. So talking about history, I want to highlight some recent efforts and progresses at Uber. So when we reach a very massive scale, so there was always a trade-off. We are kind of making multiple considerations, and a lot of time we're doing, the trade-off among some of them, right? The four major consideration is the reliability, the performance, the cost, and the security. So around that, we build several, I think it's an interesting solution. For example, for the cost, as we grow and over the time, we find our physical resources are heterogeneous. So it's not about, and you always trace a load balancing. Sometimes you need a load imbalance, to give the strong resource, so strong CPU more load and the weaker CPU less load. So that the overall goal is to reduce the peak. So that overall in the provision, we can massively save the cost. And the second I want to highlight is our zonal drain ability. So that in service mesh, it's quite norm that when you deploy some bad code by services, and it will have a big fan out, so that the incident is hard to mitigate or diagnosis. And one way is that you have reliability zone and kind of isolate, make them relatively isolated and independent. And when you have something before even the root cause analysis, you can mitigate the failure with the zone drain. So that is a very essential features in current Uber. And the third part is the global rate limiter we built. And based on that, we build our DDoS ability. So it's interesting that even if we are on top of the cloud, the cloud DDoS ability does not necessarily means it's useful for Uber, because the volume is different, and sometimes the attacker just build some DDoS attack strategy that can bypass the cloud part and directly attack the Uber. So yeah, these are already in the production and it runs well. And next, I want to talk some thoughts, what I see and what's the challenge and the research opportunity here. The first, of course, is currently we find that we have not a good understanding about the service mesh and topology. And I think the topology of the service mesh grows organically, and but the underlayer infrastructure is changing, and the requirement of the security, the reliability are changing, so that a better understanding and approach on how to construct, how to tune the topology and the routing is definitely one very critical and interesting topic. And the driver of that is, some basic question is like, when we have a heterogeneous and a hybrid multi-cloud infrastructure, and how this service level topology match that, and with the consideration of cost, the failover, right? And also how to route with the performance, reliability, cost, and security considerations simultaneously. And as I said, so the routing and topology are highly flexible and changeable. So how we change that over the time so that we can be more flexible with the workloads. That's the one. And the second one, we're also working on that, invite the academia to pay attention is the, secure service mesh. As I said, so service mesh is a smart software network layer, and the people want it more smart even. For example, they want to be a centralized hub to do the authentication, authorization, and encryption all the time. So that, but if we go into that way, so there are definitely some challenges like how to make it transparent and how to guarantee its performance, and also, due to because it's more complexity. So how we prevent the failure and the recovery. So the third part, consideration or idea I want to mention is reconsidering of the sidecar architecture. Because currently the sidecar architecture offers a very good availability, but on the other side, so we find it is also have a huge kind of cost effect, because sometimes you have to relocate the resources, and the resources is have the chance, to waste it, and putting them together as a dedicated service in a dedicated cluster can have the potential you did a multiplexing effect. And also what is important is we can have different type of clusters for different type of service. That is also essential, because you say either we add more and more services and more features in the service mesh, the service mesh itself becomes a holomatic giant that we need to consider how to break it down, make it simple, easy to manage, and also saving the cost. So for here, I will end the talk, and happy to discuss.
Thanks, Ari. Got to kick off, like just on the last slide. I think folks like Ambient Mesh are also kind of heading that direction. I always kind of wonder about one thing, like, do you now need like a mini service mesh for this service mesh, given that this network endpoint is now divorced from the application and there's a network in between that? Like, how do you kind of think about that? Like,
I think, yes, I think you're right. You're right. But I think overall, it depends on the granularity. For example, if for each zone you have a dedicated cluster, then the cluster can be relatively stable, right? You don't have to manage it too dynamically. So that's give the hope. Yeah.
Oh, I see. So you plan that topologically and just network pathwise, you can.
Yes.
To reduce some uncertainty.
Yeah, because I think the functionality required by service mesh is from the dynamics, right, and the flexibility that is needed. But for the dedicated service, it can be more stable, and then you can handle in a very old school way.